All right, so we have been discussing the portfolio of two risky assets. One is stock and one bond. It could be a portfolio of any two risky assets. And unlike the case of risky and risk-free that we looked at in chapter 5, there the relationship between risk and return was linear, right? So if you recall, we had the capital allocation line like this, straight line, right? In case of two risky assets, however, the relationship is non-linear, right? So we don't get a straight line. We get this type of a graph. Uh, and In order to plot this graph, you actually need like number of different data points and then join those data points with a smooth curve, right? For the straight line, we just need two data points. So the idea is still the same. You have risk on the x-axis, your sigma, your expected return on the y-axis, and what this graph is again showing is uh, is different combinations of stock and bond, right? So this right here is the 100% bond portfolio. This right here is the 100% stock portfolio, and the other points on this graph correspond to different combinations of stocks and bonds, right? So this is what the graph looks like. Now you see this portfolio here, this sort of diamond shape a marker there that is indicating what is referred to as the minimum variance portfolio or the minimum risk portfolio. This is the lowest risk portfolio that we can obtain by combining the stocks and bonds together, right? We can not get any lower risk with these two assets given the different inputs that we have for our calculations. Okay. Now this minimum variance portfolio divides the graph, this curve, into two parts, right? One is this lower part of the curve, and then you have this upper part of the curve. What can we say about the desirability of these portfolios on the lower part of the curve? Would any investor consider investing in any of these portfolios? Well, the answer is no, because for the same level of risk, you can always find a portfolio on the upper part of the curve that has a higher expected return, right? Let's say your desired risk level is 8%, right? So you have two choices available. One is a portfolio here on the lower part of the curve, right? And then directly above that is another portfolio on the upper part of the curve. And obviously the one on the upper part of the curve is better. Or the other way to look at it is that this minimum variance portfolio, right? It is actually better than all of these portfolios on the lower part, right? Because it obviously has lower risk, it's minimum risk portfolio, and it has higher return than everything on the lower part. So what we can then say is that we can discard all of these portfolios on the lower part of the curve. Again, our goal is to find an optimal risky portfolio. What is the best portfolio that will give us the best risk return trade-off, right? So here we are saying that irrespective of your risk preference, right, does not matter whether you're very risk averse or risk tolerant, all investors can disregard these portfolios on the lower part of the curve, and therefore what would remain are all these portfolios on the upper part of the curve, including the minimum variance portfolio, right? So starting from here and then this upper part of the curve. This upper part of the curve has a special name. It is known as the efficient frontier. All right, efficient frontier. Um, so, so you right away see some differences from our analysis here versus the risky and risk-free. In case of risky and risk-free, we said that all of these portfolios on the capital allocation line, they have the same Sharpe ratio, right? If you recall the class example we worked on, the Sharpe ratio for all of these portfolios was identical. So we could not discard any of these portfolios. All portfolios are equally good from a risk return point of view, but that is obviously not the case here. When we are dealing with a portfolio of two risky assets, we can clearly get rid of the portfolios on the lower part of the curve. All right, so that is where we are. We still have number of possible choices, right? Everything on the upper part of the curve. So we are still not quite there in terms of identifying a single portfolio that we can choose as our risky portfolio, right? But we will get there. So here in this graph, it is showing the role of correlation in diversification, right? So what we are looking at here is that as you reduce the correlation, so there are four different graphs here. The only thing that is changing is correlation. Other numbers are identical. So as you reduce the correlation, your diversification improves, right? That is actually the bottom line result here. So this blue line that you see here, the straight line, that corresponds to correlation of +1. With what +1 correlation, there is no diversification, as we have talked about. The more risk you take, the higher is your expected return. It's basically a straight line relationship. Then you go to zero point 0.2 correlation. So that is this gray colored curve here, right? So you're now getting some diversification. Then you reduce the correlation further to 0 and you have this blue curve. So what is happening as you move, as you reduce the correlation, is that your graph is moving in this direction, right? This direction here. This is the desirable direction. This is sort of this northwest direction. Northwest direction is basically where your risk is lower and your return is higher, right? So that is what you would want as an investor. So that is the desirable direction. So as you reduce the correlation, your curve, your graph of risk and return, it actually moves in that direction. And then the other extreme is -1 correlation, right? Perfect negative correlation. And there, of course, you have this curve. Here it's actually non-linear again, because it is uh, this V-shaped curve intersection of two lines. In this case, the curve actually intersects the y-axis, which means that I can actually create a portfolio with zero risk. So I can take two risky assets. If they have -1 correlation, I can combine them and create a portfolio with zero risk. And that happens only when correlation is -1, and that too with a specific combination of those risky assets, right? So that is the role of correlation in diversification. Now, what we are going to do is we are going to bring back the risk-free asset into our analysis. So far, our focus has been on combining two risky assets, right? And we basically set aside the risk-free asset. Now we are going to go back to our risk-free asset and basically just complete the overall picture here. So what would happen when I bring back the risk-free asset into the mix, right? So let's actually look at the graph here. Now I have number of possible choices here, like we said, right? Everything on this upper part of the curve, you can choose that as your optimal risky portfolio. So let's compare two choices here. Let's say I choose this portfolio A, right? I choose this portfolio A as my risky portfolio, and that is on the upper part of the curve, portfolio A. So now what I'm going to do is I'm going to put some of my money in this portfolio A. It is a risky portfolio, and rest of the money I'm going to leave in the risk-free asset, right? So now we are back to our risky and risk-free kind of scenario, right? Something like this. In this graph here that we looked at in chapter 5, P is the risky portfolio, RF is the risk-free rate. How do I get my capital allocation line? I simply draw a straight line starting from this risk-free rate and then intersecting with this portfolio P. So same thing I'm going to do there. When I choose this A as my risky portfolio, right? How will I get my capital allocation line? Here in this example, the risk-free rate is 5%, right? So this is your risk-free rate. You draw a straight line starting from that 5% intercept and going to portfolio A, right? So at this point, I can forget about all other portfolios and focus on just this combinations of A and risk-free rates, right? And we know that I can choose any combination on this line. I can be, for example, somewhere here, this would be like 70% in A, 30% in risk-free, or somewhere right in the middle, which is 50-50, 50 in A and 50 in risk-free. right? So A is a possible choice, and if I choose A, Cal A would be my capital allocation line. Suppose you choose B as your risky portfolio, right? So along the same lines, then Cal B would be your capital allocation line, right? You will have all possible combinations of B and risk free on this particular line, Cal B, and you can choose any combination here. That would depend on your risk preference, as we have discussed previously. Now comparing these two, right, Cal A and Cal B, can we say something about which one is better? Well, we can, right? Cal B is better than Cal A. Why? Because it is steeper, right? For any given level of risk, like say 10%, right? 10% standard deviation. If I want a portfolio with 10% standard deviation, with A, my portfolio would be here. With B, my portfolio would be here above A. So for 10% standard deviation, combinations of B are giving me a higher expected return than combinations of A, right? So therefore, I'm not going to choose A. I will also choose B, because for any given level of risk, I can always do better with B versus A. And therefore, I mean, if you just sort of keep uh, following this line of reasoning, why stop at B? Can you do better than B? Well, of course, you can choose a portfolio here that is even higher on the efficient frontier. What is the best portfolio that you can get? Well, just keep making this capital allocation line steeper and steeper. The steepest possible line that you can get is the one that would be tangent to the efficient frontier, right? One that just intersects the efficient frontier. This is this tangency line. So again, starting from the risk-free rate and intersecting the efficient frontier at this tangency point. Cannot make it any steeper, because you have to choose a portfolio from the efficient frontier, and anything less steep is not desirable. So you obviously then would choose portfolio O here as your optimal risky portfolio, right? So not only have we actually discarded these portfolios on the lower part of the curve, once we bring back the risk-free asset into our analysis, uh, and try to find that steepest capital allocation line, we find that we actually have a single portfolio that is better than everything else that is available, right? And this is this portfolio O. So all investors are going to choose this portfolio O as their optimal risky portfolio. Every single investor would choose O as their optimal risky portfolio. Every single investor would have this same capital allocation line, Cal O, right? Where would investors differ in? They would differ in where they are on this line, right? So again, I might choose a portfolio that is 50% in O and 50% in risk free. So that would be somewhere here, right in the middle. You may choose a portfolio that is 70% in O and only 30% in risk free. So you will be somewhere here closer to portfolio O. So our allocations across O and risk free would be different, but we will be on the same capital allocation line, Cal O, right? So now we have actually identified a single portfolio that is best for all investors. This is this portfolio O. Okay. And you can actually do the calculations here to figure out what is the composition of that portfolio. We are going to skip over that part. We are not going to be worried about how to actually determine the composition of this portfolio. We're just trying to focus on this conceptually. Okay. So this is basically the final allocation. This investor has chosen to put 55% in O and 45% in risk free. And then once you make the determination that 55% goes to O, of course, the composition of O is fixed. This is the optimal portfolio of stocks and bonds that you will get. So this is purely a mathematical exercise, right? Determining the composition of portfolio O, right? So basically we are looking at, we can do number of different things with this portfolio theory idea, we can try to get the highest return with lower risk. We can get we can try to minimize the risk for any given level of return, or we can just say that I want a portfolio with the highest Sharpe ratio, right? So you can meet any objective of any target level of risk and return that you want, or you can just choose to have the best possible portfolio from the Sharpe ratio point of view. Okay, so far our focus has been on a portfolio of two risky assets, right? This is this analysis that we did. This is for two risky asset portfolio. What happens when I have multiple risky assets, right? So most real world portfolios have more than two assets. They might have hundreds of stocks and bonds together. So when we include multiple risky assets, nothing changes as such conceptually. We are of course getting better diversification, right? The more assets you add, you are getting more diversified, so your portfolio would keep moving, or your graph would keep moving in this desirable northwest direction. But otherwise the shape of your curve remains the same, and once you add the risk-free asset, again you will get that tangency portfolio as the optimal risky portfolio. So in this graph, we start with A and B as like two risky assets, and we get this curve here. Then I add C, like the third risky asset, right? And from A and B I choose a combination E. So then I can think of E and C as like two risky assets, and I combine those two and I get this black curve here, right? So we are basically uh, just adding one asset at a time and sort of looking at this iteratively. But conceptually, all the ideas that we learned about for the two risky asset case, they will extend to multiple risky asset case as well. Okay, and then you get this final efficient frontier once you have included all the uh, risky assets in your portfolio. So there are softwares which can do this optimization for you. They can figure out what is your efficient frontier, what is your tangency portfolio once you add the risk-free asset, and so on, right? Because as you can imagine, once we add like multiple risky assets, the calculations become even more cumbersome. But there are softwares which can actually do those calculations for us, and all the individual assets of course will lie uh, under this graph, below the efficient frontier, because they are obviously not giving us uh, diversification, right? So we get a better risk return trade-off by choosing one of the portfolios on this efficient frontier, and in particular choosing the tangency portfolio when combined with the risk-free asset. Okay, so overall this um, construction of optimal portfolio, we can think of this as like two separate decisions. This is referred to as the separation property, right? One is, how do I figure out the optimal risky portfolio, right? And that is this analysis here. The optimal risky portfolio is the tangency portfolio. It's the same portfolio for all investors, right? So this is purely a mathematical exercise. There is no subjectivity. Whether you are very risk averse or very risk tolerant, it does not matter. Everybody would choose O as their optimal risky portfolio. You can plug in the numbers into a formula and figure out what that portfolio composition should be, right? So that is one decision, how to figure out this composition of portfolio O, that is purely objective. The second decision is how much to put in O and how much to put in risk free, right? Capital allocation across O and risk free. And as we know, that is purely subjective decision. That would depend on your risk preference, right? Where you want to lie along this capital allocation line. So two separate decisions together will lead to this optimal choice of your portfolio. One is purely mathematical, determining the composition of this optimal risky portfolio, and the second one is the allocation between this risky portfolio and risk-free asset, that is dependent on your risk preference. So that is a subjective decision. All right. So that concludes our discussion on diversification, and this result here, that the tangency portfolio is the optimal portfolio. This is actually the foundation for CAPM, right? And so we are going to start CAPM next, and And CAPM is based on this idea that the optimal portfolio that you're getting is the tangency portfolio. Okay, so let's think about this a little bit before we conclude. If everybody holds the same portfolio of risky assets, right? So my portfolio of risky assets is O, your portfolio is O, all other investors in the market have the exact same portfolio O, then what should be that portfolio? Well, that portfolio should be the entire market, right? I mean, everybody is holding the exact same portfolio. So everything that is out there in the market has to be part of that portfolio. Nothing can be left out, right? Every single risky asset should be part of this portfolio. If something is left out, that means no investor is holding that asset. And obviously that is not possible. Either that asset does not exist, or if it exists and nobody is holding it, that means its price would fall to such a level that it becomes instantaneously attractive to add to the portfolio, right? So this portfolio O is the market portfolio. So that is actually a very sort of strong and interesting result, that the best portfolio for all investors is the market portfolio, right? That is of course based on some assumptions. The key assumption of course here is that everybody is doing the same analysis, coming up with same inputs, and if the inputs are same, then of course the optimal portfolio that they arrive at would be same. In reality though, of course the inputs are not same. My expected return for a stock could be very different from your expected return for the stock. So if we are using different numbers in our analysis, then of course we are going to get a different efficient frontier, and therefore we are going to get a different optimal portfolio. So the assumption here is that the optimal, I mean the inputs are same for everyone. Everybody is coming up with the same input. So that is one of the assumptions that we have to make for CAPM as well. But the key idea here is that the optimal portfolio is the market portfolio, and like I said, that result is the foundation for CAPM. So we'll start talking about CAPM next.